इक्विलिब्रियम। ओके, सो 1 2 3 क्वेश्चंस जो हैं वो हम कर चुके हैं और मैं आपको वीडियो भी शेयर कर दूंगा। फोर्थ क्वेश्चन वी विल डू टुडे। फोर्थ क्वेश्चन, ओके, सो फोर्थ क्वेश्चन इज राइट expression for the equilibrium constant for the following reactions. Reactions are given to us. Okay, first reaction is 2 NaCl gas to give 2 NO gas plus Cl2 gas. Okay, this is the first reaction. Now let us do one by one. For the first reaction, let us write the expression for the equilibrium constant. So say, yes, Kc for this reaction is, yes, you know, concentration of NO gas raised to power 2 into concentration of Cl2 gas raised to power 1 divided by concentration of NaCl gas raised to power 2. So this is the expression of for the equilibrium constant of this particular reaction. Okay. Second reaction is 2 Cu NO3 twice solid to give 2 CuO solid plus 4 NO2 gas plus O2 gas. Okay. So let us write the expression for this one. तो अब देखो इस केस में if you write Kc, you know, it is CuO solid raised to power 2, NO2 gas raised to power 4, O2 gas raised to power 1 divided by Cu NO3 twice solid raised to power 2. Okay. So now look at the expression. This CuO is solid, CuNO3 twice is also solid. So keep in mind, for the pure solid or pure liquid, we take it as unity, because concentration of pure solid and pure liquid does not change, because it depends on the density. There is a separate video for this, but you should keep in mind, whenever there are pure solids or pure liquids in the expression, then that should be omitted while writing the expression for the equilibrium constant. That means it should be, now this part CuO solid and CuNO3 twice solid, that should be omitted. So final expression is actually you should write NO2 raised to power 2 and O2 gas raised to power 1. So this is the actual expression. Sorry, it is 4. So it should be 4. That's it. Now third, this is the second expression. Now third one, third reaction is CH3COOC2H5 aqueous ethyl acetate plus H2O liquid to give CH3COOOH, means acetic acid aqueous, plus C2H5OH aqueous. Now look at the expression. These are aqueous solutions. This one, this one, this one. These are the aqueous solutions of ethyl acetate acetic acid and ethanol, ethyl alcohol. Okay, but this one is pure liquid. So as I told earlier, that for pure solid and pure liquid, they are not written in the final expression, but let us write first all the constituents, product of the concentration of the products, that is acetic acid aqueous, ethanol aqueous concentration का product divided by aqueous solution of ethyl acetate concentration and H2O liquid concentration. But you know H2O liquid we should not write. So now it becomes CH3 COOH aqueous C2H5OH aqueous divided by ethyl acetate aqueous. So this is the final expression. You should write it like this. There is no need to write H2O liquid in the final expression. Now fourth one is Fa3 plus aqueous plus 3OH negative aqueous to give FaOH thrice solid. So let us write for this. When you write expression for the given Kc is concentration of FaOH thrice solid, but I told you earlier that there is no need to write this expression. So it should be actually 1 upon Fe3 plus aqueous OH negative aqueous raised to power 3. There is no need to write for solid. Okay, for pure solid and pure liquid we should omit, because for pure solid and pure liquid it should be taken as unity. Okay. Now fifth one is I2 solid plus F2 gas to give 2IF5 liquid. So now Kc for the given expression, it is IF5 liquid raised to power 2, I2 solid and F2 gas raised to power 5. Okay. So obviously this is pure solid. This both should be omitted, because it is, if it is written as a liquid, so its expression should be F2 gas raised to power 5. And for the sake of convenience, you can write for the product as well if you wish to, but there is no need to write it as well. Okay. So these are the expressions. This is the question number 4. Now question number 5. Find the value of Kc for each of the following equilibria from the value of Kp. First expression is 2NOCl gas to give 2NO gas plus Cl2 gas, and Kp for the given reaction is -2 atmosphere at 500 Kelvin. Value is 167 atmosphere at 1073 Kelvin. So let us solve it. See, Kp is given to us. We have to calculate Kc, and relation between Kp and Kc is, it is equal to Kp equal to Kc RT raised to power delta Ng. Okay, here you know R, value of R, because see, pressure is given in atmosphere, so value of R, it is 0.0821 liter atmosphere per Kelvin per mole. Values of R you know in different units, but here as Kp is given in atmosphere, so we should take R in terms of atmosphere. And temperature, here it is 500 Kelvin. Now what is left? Delta Ng for first expression. So delta Ng is number of gaseous moles of product minus number of gaseous moles of reactant. So for the product, total moles are 3, 2 NO gas and 1 Cl2 gas, minus in case of reactants it is 2. So delta Ng for the said reaction is 1. Okay, so just put the value. So from the relation Kc is equal to Kp divided by RT raised to power delta Ng. Now Kp is given to you, value is 1.8 into 10 raised to power minus 2 atmosphere divided by 0.0821 liter atmosphere per Kelvin per mole into 500 Kelvin, okay, and raised to power 1 only, because delta Ng is 1. Okay, so from this relation Kc is equal to, yes, 1.8 into 10 raised to power minus 2 atmosphere divided by 0.0821 into 500. See, per Kelvin and Kelvin cancel. So what will have at liter? Atmosphere per mole. Atmosphere cancel. See, this atmosphere cancel. Here per Kelvin cancel. So what is left? Mole per liter. See, 1.8 into 10 raised to power minus 2 divided by, see, this is 500, okay, and this is 0.082. So with 500, it is 0.0 into 500 and unit is mole per liter. Unit of Kc is now mole per liter. Okay, so solve it. What is the value? Say I take it as 18 into 10 raised per minus 3, and this one, see, it is 8 5s are 5, 5 to the 10, 0, 4105, okay, 4105, and see 2 decimal, so it is 41.05. So 18 divided by 4.105 into 10 raised per minus 4. So 4 4s are 16 and 20, okay, but it is 4.105. So 4.4 around into 10 raised per minus 4 mole per liter, because if it is 4 it should be 4.5, but it is more than 4, so it is, I take it as 4.4 into 10 raised per minus 4. Now second part is calcium carbonate solid to give calcium oxide solid plus CO2 gas. Tell me what is delta Ng? Here again Kp is given to you 167 atmosphere. R, you know, we have discussed just now, and temperature now it is changed, it is 1073 Kelvin. It is all given to you. Okay. And what is delta Ng? Yes, beta. What is delta Ng in this reaction? Because there is gaseous moles of product minus gaseous moles of reactant. Only gaseous moles we will consider. So it is 1. Okay. So again Kc equal to Kp divided by RT raised to power delta Ng. And what is Kp? 167 atmosphere divided by 0.0821 liter atmosphere per Kelvin per mole into 1073 Kelvin raised to power 1. Raised to power 1. Okay. So tell me, what is the result? So calculate the answer. For the time being, I will write next question. Okay, so value comes out to be 1.87. Okay, so units are same, mole per liter. So Kc is 1.87 mole per liter. Next question, question number 6. Say for the forward reaction, say for the following equilibrium Kc is given, means Kc is given for the forward reaction, right? Now both forward as well as backward reaction, means reverse reaction, are elementary bimolecular reactions. See, elementary means one step reaction. Elementary means one step reaction. Okay, bimolecular means only two molecules are involved. Okay, so we calculate Kc. So Kc for the reverse reaction is equal to 1 upon Kc for the forward reaction. Yes, Ralam has written already. Okay, Kc for the reverse reaction equal to Kc for the forward reaction, and Kc for the forward reaction is given to us. It is 6.3 into 10 raised to power 14. That's it. Okay, so it becomes 1 upon 6.3 into 10 raised to power minus 14. That implies it is 10 upon 6.3 into 10 raised to power minus 15. So value comes out to be, yes, 6.3. It is 1 almost 6 into 10 raised to power minus 15. That's it. Very easy question. You can do it easily. Now next question is, explain why pure liquids and solids can be ignored while writing the value of equilibrium constant. That is already done. I will share the video. Okay, but it's because their density remains same, and you know density is an intensive property which does not depend upon the mass of the substance. That's why they are ignored. Okay, that is question number 7. Okay, now question number 8. So reaction between, question number 8 I will write first. Okay, देखो रिएक्शन है बिटवीन नाइट्रोजन एंड ऑक्सीजन एंड टेक्स प्लेस एज फॉलोज. ओके, तो फर्स्ट ऑफ ऑल जब सोल्यूशन लिखोगे आप, क्योंकि क्वेश्चन तो गिवन होगा आपको, यू शुड फर्स्ट राइट द रिएक्शन एज सच कि गिवन रिएक्शन इज, है ना, ये आपको रिएक्शन गिवन है. ठीक है, ये रिएक्शन आपने वापस लिख दिया जो क्वेश्चन में दिया है रिएक्शन. ठीक है ना. नाउ सी mixture में 0.482 mole of nitrogen is there and 0.933 mole of O2, and they are in the vessel of 10 liter, not 1 liter. Okay, so that means initial moles, first of all write initial concentration, we can write. Okay, initial concentration. So initial concentration of nitrogen is 0.482 divided by 10, because concentration is in mole per liter, right? Initial concentration is 0.482 divided by 10. Okay, this is mole per liter, and for oxygen it is 0.933 divided by 10. Okay, mole per liter. And what about N2O? 0, because initially we have only two. What we have initially? We have only two things, that is N2 and O2 gas, and their moles are 0.482 and 0.933 O2. Okay, got it? Now at equilibrium, what is equilibrium? That we have done. At equilibrium means when reactants are converted into product and rate of the forward reaction becomes equal to rate of backward reaction, means concentration of nitrogen, oxygen and N2O will not change afterwards. After equilibrium it remains constant. Okay, so let us say that out of 0.482 moles, how many moles are decreased? X moles of nitrogen. So if X moles of nitrogen are decreased, what about the moles of O2? Obviously X by 2, because if 2 moles of nitrogen are taking part in the reaction, then 1 mole of oxygen taking part. Okay, that's why if I take it as X, so it is X by 2. If it is X, it is X by 2, and it is again X. That's why better to write N2 as X and O2 as X by 2. Means if X moles of N2 reacts, then at the same time X by 2 moles of O2 reacts and we get X moles of N2. See, this is like this: 2, 1, 2. 2 moles of N2 react with 1 mole of O2 to give 2 moles of N2O. It is like this. So 2x moles of N2, then x moles of O2 to give 2x moles of N2O, or x mole of N2, x by 2 moles of O2 and x moles of N2O, right? It is moles, so concentration is divided by 10. You know what is the value of equilibrium constant? The value of equilibrium constant is 2.0 into 10 raised to power minus 37. See the number, 10 raised to power minus 37. It is extremely small. What it means? That only small amount of reactants have reacted. Very small amount of reactants have reacted, that means X is extremely small, and that's why can be omitted as far as reactants are concerned, because see, this X is decreased from 0.482, X by 2 is decreased from 0.933, and this value is very less. That's why it can be neglected. If it is neglected, then what would be the concentration of N2? So N2 gas concentration is See, it is 0.482 minus x divided by 10. So, x can be neglected as compared to 0.482. So, it is actually 0.482 divided by 10. And for O2 gas, it is 0.933 minus x by 2 divided by 10. So, now it is 0.933 divided by 10. I said that value of Kc is very less. So, as value of Kc is very less, it can be neglected. It is extremely small. That is why a very small amount of reactants have reacted. If very small amounts of, extremely small amounts of reactants have reacted, which are almost negligible as compared to 0.482 of N2 and 0.933 of O2. So, we can omit X as far as reactants are concerned. But if you talk in terms of product, see, N2O is product, but there is no another number. That is why, say, X remains intact. You should not take it as 0. Okay. X by 10 remains as such. They are neglected because they have compared with 0.933 and 0.482. Okay. So, this is the thing. Now, just apply law of chemical equilibrium. So, if you apply law of chemical equilibrium, you know what is Kc? Kc is equal to, yes, Kc is equal to concentration of products raised to the stoichiometric coefficient divided by product of the concentration of the products, reactant, sorry, raised to power their stoichiometric coefficients. Okay. So, in this way, value, these are the values at equilibrium. Okay. So, you know, Kc is 2.0 into 10 raised to power minus 37, that is equal to N2O x by 10 raised to power 2 divided by 0.482 divided by 10 raised to power 2, 0.933 divided by 10 raised to power 1. So, it comes out to be, yes, 0.1 x raised to power 2 divided by 0.00482 raised to power 2, sorry, 0.0482 raised to power 2, 0.0933 raised to power 1. Okay. So, now it is 0.01 x raised to power 2. So, what is the value after multiplying? Siddharth, just attach it to the nearby socket. It comes out to be 2.1676 into 10 raised to power minus 4. Okay. So, in this way, x square equal to x square equal to 2.0 into 10 raised to power minus 37 into 2.1676 into 10 raised to power minus 4 and divided by 0.01. So, on multiplying, value comes out to be 43.352 into 10 raised power minus 40, and x is 6.6 into 10 raised power minus 20. So, see, x is extremely small and can be neglected. See, x is 6.6 into 10 raised power minus 20. Okay. So, question was to calculate, what was the question? To calculate the composition. Okay. So, what was the composition? What is the composition of all the compounds? So, in equilibrium mixture, what is molar concentration of N2? Molar concentration of N2 is 0.0482 mole per liter, and molar concentration of O2 is equal to 0.0933 mole per liter, and molar concentration of N2O, that is equal to, yes, 0.1 into x, it is x by 10. Okay, so that means 0.1 into x, that means 0.1 into 6.6 into 10 raised power minus 20. So, it comes out to be 6.6 into 10 raised power minus 21 mole per liter. So, that is it.